So thank you guys so much for taking the time to meet with us this morning/afternoon. I'm Jessica Cash here with David McLansborough, representing Design Mechanical. Our goal for today's presentation is to educate you on how to protect your business, your employees, and your patrons from COVID-19 through various solutions regarding HVAC. We will leave time for questions at the end, but feel free to chime in on the chat feature. We will be checking it throughout the presentation to answer your questions as we go, as well as at the end of our presentation this morning. So COVID-19 is not a rarity. At this point, everyone's familiar with COVID-19 and is seeing a direct impact on their lives. While this pandemic is probably the worst pandemic most of us have experienced throughout our lifetime, it is following a trend over the last 100 years, which exponentially increased over the last 50 years. In 1918, there was the first H1N1 outbreak. Approximately 50 million people died worldwide, with 1.1 million people, approximately 50 million people died from the H1N1 virus, including 675,000 Americans. Now, if you fast forward to 1957, when the world was impacted by the H2N2 virus, it killed 1.1 million people across the globe, with 116,000 people in the United States. Just 10 years later was the 1968 H3N2 virus, which took another 1 million lives worldwide, including 100,000 lives in America. Then in 2009, we experienced the H1N1 virus all over again. This influenza took approximately 12,500 US deaths and an estimated 300,000 lives across the world. This unique virus, though, had 80% of the deaths occur in people 65 and younger, probably because of the antibodies present from anyone older from the 1918 Spanish flu. And now we are living in the era of SARS-CoV-2 virus pandemic. As of this morning, there has been an astounding 125,000 US deaths, with the toll increasing every minute and not seeming to stop, with approximately 483,000 people died across the globe. In addition to these pandemics, since the year 2000, we've seen outbreaks of Ebola, Zika, West Nile virus, SARS, and MERS. As the graphic on the slide demonstrates, there is a clear correlation. There is a clear correlation between climate change, global population, and rise in pandemics. These pandemics will continue to rattle our society as we embrace the global economy. As populations rise, more cities are built, which leads people in smaller areas. This makes containment harder and contracting viruses easier. You could be on a flight going from Denver to New York and be with people from 26 states or even 26 countries on the same plane. With globalization, we cross paths with people from all walks of life, which makes infectious disease spread fast. If you had told me 6 months ago, if you had told me 6 months ago that I'd have to wear a face mask to go grocery shopping or sanitize and wash my hands relentlessly to prevent infection, I would have balked at you. However, with COVID-19, we are all forced to face this new normal. On the HVAC side, what I do for a living, if you had told me 6 months ago that my customers would be asking for MERV 13 filters and asking to increase their filter changes and frequencies, or turning to me for consultation on disinfecting coils, I would have balked at you too. COVID-19 has impacted all of our lives, and as facility managers, it is your responsibility to adapt to this new normal for your employees, your buildings, and your patrons' safety. This presentation will demonstrate a meaningful impact of taking preventative measures for your airside heating and cooling systems. As I mentioned, based on ASHRAE's recommendations, many of my clients are asking about MERV 13 filters. The MERV is the minimum efficiency reporting values for your air filters inside of your HVAC equipment. These filters are significantly more expensive than the standard MERV 8 filter. With both an increase in raw material costs and new social distancing guidelines for workplace capacity, COVID is costing us more while forcing many businesses to have decreased revenue. In addition to upping MERV ratings, my clients are requesting filter changes from quarterly to monthly in order to limit the exposure the virus may have on living on their filters, and infecting their employees and their patrons that could have traveled throughout the building's airstream. Filters leaving an infected facility need to be bagged and disposed of differently than filters in the past. We need to ensure proper PPE worn, removed, and replaced by technicians in order to keep them safe as well. On the next slide, we will show you what the different MERV ratings mean, and then Dave will speak in greater detail about filtration. I've also had customers asking me about sanitizing units and coil cleaning. We will address these methods in depth throughout the presentation in order to educate you on the different methods to protecting your facilities and your people. On this slide is the MERV rating chart. In this graphic, we can see what different MERV ratings actually mean for your filters. The industry standard for your makeup air units, your air handling units, and your rooftop units is a MERV 8. For your fan-powered VAVs and your water source heat pumps, you might even see MERV ratings of a 4 because they have pre-filtered air through your makeup airs and air handling units. As you can see from this graphic, 0% of the microns between 0.3 and 1 micron are filtered out in this MERV 8 range. Aerosols, which are the particles that the virus attaches to, are in the precise range that MERV 8s do not filter out. So when increasing your filters to MERV 13s, you are reducing the amount of aerosols entering your facility's airstream by over 50%. And now I'm going to turn it over to Dave, who's going to speak in greater detail about filtration, dilution, disinfection, containment, UV light, and humidification.
Wow. Debbie, do we have a question?
We have a polling question. Let's go ahead and launch that poll. Yes, thank you. Everybody should see a polling question on your screen. Go ahead and mark your selection. We'll give it another couple seconds before we see the results. All right. Share results. There we go.
So I appreciate your answers, but only one person got it right, and I think I know who it is. So HVAC systems actually use 50% of your water bills, your gas bills, and your electric bills. Pretty crazy.
Thanks.
Got it.
Okay. Is that going to drop off? No. Okay, so let's talk about filtration. It's actually, even with the increased cost of going to MERV 13, it's one of your very best low-cost options. This is probably one of the most effective things that you can do in your building to reduce the amount of infectious aerosols and microbes running around in your building. How does it do this? Well, no filter will actually catch virus. Viruses are extremely small. They ride around on dust, aerosols, that type of thing. And so but thank God they don't travel very far by themselves. They have to be attached to something. So when we use filters, we're targeting filters to go pick that dust and those particles up, or those aerosols up. And so we recommend using and ASHRAE recommends using the very best filters that you can have for your particular unit. Now, there's a lot of people out there right now that are recommending higher than MERV 13 filters. We wouldn't recommend that and I'll get to that in just a second. These filters if we can't, if you don't want to go too far on all of this, you don't want to go so far as you're going to start to impact the performance of the, air handling. So, because if you actually increase the filters past a certain point, you'll use more energy, you'll have reduced airflow, and it can cause problems with short cycling of the heating and cooling on the units. With all of the filter formats that are out there now, like there's 2-inch and 1-inch MERV 13s, they should be able to fit in just about any type of unit. So that would be our recommendation to you. Another type of filtration is...
Sorry, I don't know what's going on.
It's not.
Sorry. There you go.
Debbie, can we drop the poll off? Is that?
I did. You still see it?
Yeah.
Oh, press the X at the top. It's not showing up on my.
Okay. Okay. Sorry. I thought everybody was seeing it because I was seeing it. Okay. So let's talk about electronic air filtration. This is a technology that's been around since 1970. In fact, I worked on a system back in the 80s. It was at the Stapleton Airport. They used it to, drop out the soot from jet fuel. So this is very effective in picking up small particulate. It basically, the way it works is it ionizes the particular dust or whatever, or the aerosols going through it. And what happens is they stick to each other and then they drop out of the airstream. They do this with little or no pressure drop because there's, basically each one, they're probably 3 or 4 inches apart. So there is no pressure drop to the array. But it doesn't replace filtration. We've seen some people that have come in and offered huge energy savings while going to electronic air cleaners. The problem with it being, if you're not doing other filtration, yeah, sure, you'll ionize all of this, but what it'll do is it'll contaminate the array. You'll end up having to clean the array all the time. And then secondly, you'll actually see stuff drop out on the floor of your area that you're serving. It'll actually increase dust levels on that. So we recommend that you have kind of an engineered solution where you're working with a good filter, and then this is just an add-on to that. So that would be our recommendation for electronic air cleaners. Some of the other things that you can do besides filtration to control infectious aerosols, probably the next best would be dilution. Basically, ASHRAE is recommending big increases in outside air. As facility managers, I'm sure you guys have all heard about sick building syndrome and that type of thing. Most of the buildings in the United States still to this day have low or no outside air. Most of it's in the mid-market. I mean, higher end buildings don't have that issue, but it's still it's most of the square footage that you see. So that creates high absenteeism, and productivity is impacted. In the case of COVID-19 or in any infectious aerosol, it's a major contributor to airborne infections. You'll end up with kind of a viral soup if you end up with no outside air. So this is a very effective way to reduce the amount of exposure. Basically, what we're doing is just taking the outside air component and increasing it. Our recommendation and ASHRAE's recommendation is try to get it as high as your equipment will allow. But in most cases that you can get that up into the 25 or 30% range without a lot of impact. If you have equipment that's already constrained by some issue, obviously you may not be able to go that high. If you want further information on this, ASHRAE 62.1 2019 gives you a lot of guidance on this. Any HVAC professional or engineer can help you with that because it's kind of dry reading. So next one is disinfection. There's a lot of changes in disinfection out there. With the COVID thing, everybody's now trying to get into that business. So we've got a lot of different new approaches to disinfection. First one is needlepoint bipolar ionization. Global Plasma is one of the vendors for that. Here they are basically ionizing the airstream enough that they're actually impacting virus. It ionizes the virus, and the virus basically fails. Next one is photocatalytic oxidation. An example of that is the RGF or aeroside. In this case, what they do is they shine UV light on a catalyst. Typically, it's titanium oxide, and it drives off reduction, oxygen particles, and then basically some gaseous hydrogen peroxide. So basically what it's doing is converting the oxygen to an aggressive thing to kill virus. On corona discharge and bipolar ionization, very similar things. Basically, they do exactly the same thing. They're trying to create, ROS stands for reactive oxygen species. There's a group of different oxygen types of things, peroxide being one of them, ozone being another, and then there's a bunch of others. It creates those, and those go after the virus. Airfix is an example of that. And then there's also old technologies that we've used for forever for higher risk environments where we do isolate and clean. You can actually use ozone. There's still some ozone providers out there. In the case of ozone, you need to isolate the room completely, and it's got to be contained. You will need to exhaust it afterwards, but and then the hydrogen peroxide, you can end up with kill rates clear up into the 99.999 range. So those are some of the disinfection. What's that?
I think we have a question. It says, how long does the light need to hit a surface to kill the virus?
Basically, and what I'm going off of here is airflow. When you're doing, and we're going to talk about air disinfection in a minute, it's like 0.2 seconds is what it needs to be exposed to the light to be able to kill it. So, and I'm sure that would be the same on a surface. You're actually exposed a lot longer on a surface, so you'll probably have a higher kill rate too. Okay. Next one we're going to talk about is actually UV light. Nice segue there. So, in UV light, we've all heard about it. I mean, we've all had a sunburn. Well, if you've had the sunburn, you've experienced UVA and UVB. Basically, that's what's in sunlight. UVB being the more damaging sun rays. UVC is the wavelengths that we're using for disinfection. There's been tons of studies on this. Basically, it's the most studied disinfection protocol out there. It's been around since the early 1900s. It was used for tuberculosis wards back in the day. And there's lots and lots of peer review information on it. So they've identified that the most effective wavelength of that is 257.3 nanometer. That's based on a bunch of studies and that type of thing. There's a bunch of other wavelengths, but this is by far the most effective, and this is what most people design to. You will also see over on the left-hand side, you'll see far UV. We're going to talk about that a little bit later, but basically it's much shorter wavelengths. It doesn't seem to be as effective on virus. I don't know why, just because, basically all of these, the energy level goes up dramatically as you go from UVA to far UV. The shorter the wavelength, the more energy it has, and the more damaging it can be to any kind of a cell. One thing with the advent of COVID is we're seeing a lot of different new packaging for UV. They kind of fall into a bunch of different areas though. Basically there's cooling coil disinfection, which has been around forever. You can get this from any of your rooftop manufacturers. They have it as an option. We've done retrofits of this. Basically, it does a great job of killing anything that's on the coil and keeps the coil clean. So in addition to attacking anything that's infectious aerosol, you're getting rid of mold and that type of thing. Airflow disinfection, basically what we do is we take a portion of the ductwork and we put a lamp in it, a lamp array in it, and then basically size it to run at about 500 feet per minute and get that 0.2 second, 0.2 second contact time. And so, it works very well. It'll basically kill, it's got a very high kill rate, but you have to put a lot of engineering into it. And then also the temperature of the air passing through it doesn't affect its performance. So if you're downstream of a coil, you got to derate it for the cool air. Another one is upper room. I'm sure, I don't know if anybody's seen a waiting room or food facility where you'll see kind of a UV light that's shining up on the ceiling. This is the upper room application. Basically what happens is the HVAC system stirs the air up at the top of the room, and as it goes by this light, it kills it. So with a 0.2 contact time, it does a very effective job of killing this. You've seen this used to be very popular in waiting rooms and doctors and that type of thing. It seems like we've kind of moved away from it, but there's been a lot of, it's starting to become more popular. As I was talking before, with COVID, we're seeing a lot of different packaging. Now there's a lot of people coming out with pulsed UV, where basically they use a xenon lamp to generate UV, and that at really high energy levels, i.e. it's a very large, it has a very large kill radius. You'll see this in a lot of the portable units that they're using in hospitals and that type of thing. The one thing though, the early studies on it really don't show that it does much, it's much more effective than the standard continuous light. Basically, I think with the pulse, you don't end up getting the kill, the kill rate falls off a little bit, even though you have a higher energy. Then finally, there's some talk about people are experimenting with far UV. There's a couple manufacturers out there that claim they can put a far UV light in the ceiling of the room, and you can have people in there and they'll still kill virus. Initial studies indicate that basically if you have a person in the room, you're probably not killing a lot of virus. This stuff, UV will give you burns if you're exposed to it. So you have to have safeties in various places to, like if somebody enters the room, it has to shut off, or if somebody opens a ductwork up for the airflow disinfection, it has to shut off. And it can also cause damage to the retina of the eye. So it is nothing to really mess around with as far as, it's very effective at killing virus, and it's very effective at killing our cells.
Debbie, can you give us one of the other poll questions? Because I don't want to cram them off the end.
Yeah.
Thank you.
All right. What is a swamp box?
Swamp box.
Go ahead and mark your answer. We'll give another minute. Looking good.
So.
All right, let's share those results.
Wow, we had a resounding amount of you that answered the question correctly. Yes, a swamp box, aka swamp cooler, is an evaporative cooler that basically cools you down by taking water out of the air and using it to cool the system. And when I moved from New York to Colorado, I had no idea what a swamp cooler was. I thought I was looking at a weird condensing unit, but now I know a little bit more about cell decks and aspen pads, so. And back to Dave.
Okay, I especially like B. I would have voted for B. Okay, so another one that we don't really talk about a lot, but it's something that you definitely need to look at is containment. And this is where we're using airflow and pressure gradients to control cross-contamination with infectious aerosols. This is the type of thing that we use in laboratories, on a very large basis, but even in your standard office building, this is something that you need to look at. One example of where we got called in on a health club, basically they remodeled a retail space, and we got to looking at airflow paths and return paths, and they were pulling air from their kids room with all of those little balls and and little kids over the top of their access entry area, okay, where everybody checks in. And so we ended up having to change. We put other ductwork in to get them a different path and that type of thing, so they couldn't draw that air back. And then secondly, made sure it was on a different air handler too, kind of a dedicated unit, because basically the kids' rooms and some of the locker rooms are kind of considered your highest risk environments in an athletic club. So that's an example of that. Basically, we just need to look at how are you using airflow, to kind of contain higher risk areas. One big thing that ASHRAE is really talking about is source control through exhaust, especially in bathrooms or restrooms. There's been studies showing that basically flushing a toilet can aerosolize any virus that may have been in the toilet.
And hand dryers, actually, bacteria and viruses need two things to grow: heat and moisture. So flush the toilet, particulates get in the air, and then you use a hand dryer, and then they're multiplying. So
yeah,
do it.
So you end up, they highly recommend having the exhaust on 24/7, one, and then secondly, be sure that you have an exhaust. There's some places that we've actually seen where the exhaust fan doesn't work, or the exhaust is, it's been defeated or whatever, or that type of thing.
I think everyone's probably experienced a bathroom or two that needed better exhaust. You don't want to be that guy.
Okay, and then finally, ASHRAE talks about there's a whole bunch of special requirements for healthcare. You guys in healthcare, I'm sure, are somewhat familiar with them. They go into a lot more depth as to containment of virus, especially when it comes to ED areas, ICU, et cetera, et cetera. Go ahead. Yeah. Okay. Finally, one that's been kind of in the news of late is how does humidity affect the virus? There's been a lot of studies that show that higher humidity levels typically, kill infectious aerosols. They're not sure about how it does it. There's some theory that basically, if you have an infectious aerosol and it's in a dry environment, it dries out just a little bit and it makes its lipid shell a little tougher, so it hangs around and goes further. So, but they're not sure about that. They also have some other data that goes the other way. There's earlier indications that indicate that this would attack COVID too, just like it would any other infectious aerosol. There's one problem with it in Colorado, so why don't we raise the humidity level in all of our buildings? Well, in Colorado, due to our dry air in the wintertime, your humidification costs would typically exceed the heating bill for the building because it takes a lot of energy to make humidity. I mean, either natural gas or electric. So typically with us, we recommend, if you've got another reason to have humidification, such as in healthcare, surgical suites, et cetera, be sure that you're running and, try to run up in these ranges. But if you don't have a humidity requirement for any other process, it is a fairly expensive way to go to attack the virus. So, and with that, I'm going to turn it back over to Jess.
Can you give us another poll question, Debbie?
Absolutely.
Thank you.
What is a CRAC unit? Go ahead and mark your selection. All right, and we're done.
Well, 100% of you got it correct. It is a computer room air conditioner. I forgot I'm talking to a bunch of professionals here. I did, however, trick both my boyfriend and my best friend into thinking it was D. So to wrap things up, we just want to kind of go over how Design Mechanical is recommending you embrace this new normal. We talked about filtration, upgrading your filters to MERV 13 or MERV 14. You should consult with your HVAC provider to make sure that upgrading these filters for your makeup air units and air handling units will in fact not impact performance. You don't want to put those on any fan-powered VAVs because the static pressure would go all wonky. In addition, ASHRAE is currently saying to run your HVAC 24/7. Now, as we know from question 1 in the polling, that's 50% of your water, your gas, and your electric bills. So that can be a very expensive option, but ASHRAE is currently working on the guidelines to what we're going to do as we get back to pre-COVID conditions and adapt to those. As Dave mentioned earlier in the presentation, we also are recommending that you increase your outside air to 25 to 30%. This is true, COVID or not. You want the more fresh air, the less sick people syndrome in your building, and the better everything's going to function. As we've talked about, you want to run your restroom exhaust continuously. A lot of bacteria and viruses are bred in your restrooms, and it's really important that you continue to use it the same way that you would a biological safety cabinet. You want to have it negatively pressurized and pushed out of your facility. You got to make sure that you are giving your employees and any workers that they're working on your equipment, make sure they're using proper PPE, please. If someone in your building is contaminated, the airstream going through the dampers and VAVs throughout the facility, and that technician is not wearing gloves, or they're not throwing, and they just throw this gross filter out in your dumpster and it's not bagged and properly sealed, we can further get people sick. And the whole point of this presentation is helping you guys learn how not to get people sick. One other thing I want to touch upon is coil cleaning. As I mentioned in the beginning, a lot of my customers are asking, can they use disinfectants or sanitizer coil cleaners? In the state of Colorado, there is no coil cleaning permitted. You would need an MS4 permit because all of that water from the roof, cleaning the coils, would then fall into the storm sewer drain system. Colorado is one of 2 states across the country that only exports water. So whatever contaminants you're putting on your coils, not only get into our water supply, but you're impacting people on both sides of the Mississippi. And in order to do your best due diligence, you and your employees that are working on the maintenance of your building should keep a daily log of all of your maintenance activities and any changes. This will just protect yourself if someone tries to sue. I am not a lawyer giving legal advice, but it's always best to monitor and log these things for your protections. In closing, you can reach out to Dave and myself at Design Mechanical if you would like a little bit more consultation on how we can help you with your building. I know we went over a lot of very scientific, high-level stuff today, and if you had some questions, feel free to ask them now. We'll be looking at the chat a little bit more. And you know, your HVAC system should be a part of, your HVAC system, everyone has them. Your house has heating and cooling, your work, your car, everywhere has it. So taking these preventive measures, we can help stop spread this COVID-19, help the pandemic reduce back to normal life, and stop wearing these face masks because they're making me break out. Thanks, guys.
Okay.
We can now take any questions you
have.
have.
Go to the last slide there. There's one last slide.
Oh, yes.
Yeah.
Last slide.
Yeah.
So these are some of the resources that we used. They're pretty much got everything from ASHRAE. All of my statistics on the pandemics in past life and death tolls came from the cdc.gov's website as well.
Yeah, and this is great reading for any of you to go and read. It's ASHRAE stuff, but at the same time, it kind of gives you what their thinking is and all of that. They also have a bunch of post lockdown type of information to kind of help you make the transition now from a lockdown to a more open area. They've got some recommendations there. So I would really recommend that you look at some of those websites and spend a few minutes with them.
So I wanted to answer a question that I saw come through. Where did it just go?
Yeah, it's on the MERV 11.
What?
What is the best solution for both cost and filtration? Why is MERV 11 best? Isn't the best?
So MERV 11 is a filter, actually, and MERV 10 is a filter I've seen a lot of times in like a laboratory facility, maybe a CBD compounding facility. MERV 11, a lot of times, if you, let's just take a train unit, right? Like a packaged train makeup air unit or rooftop unit. They are pre-designed to accept MERV 8 or MERV 13 filters, depending on what factory settings. In order, if you wanted to use a MERV 10 or MERV 11 filter, as the filters increase in their MERV rating, the material itself is thicker. I have actually different samples on my desk that show that the medium, it allows less to go through it. However, your machine is designed to take a certain, just increasing your outside air and is going to help push more air through those MERV 13s, those MERV 11s, MERV 10s. But really, the best solution would be to look at your model serial number, call your HVAC provider, and see if that can be used for you. We are able to retrofit units in order to ramp up the RPMs, to allow more fresh air so that you can still have it flow through the unit.
We can change fans and things like that, but it gets expensive to do that.
Yeah.
And again, if you look at the ASHRAE guidance, they really recommend taking it up to a 13 to 14 range. Again, from when Jess was showing the MERV rating chart, you're starting to get better containment of those, the ones in the range that we need to catch for catching aerosols. So that would be our recommendation. If your equipment can't handle it, then yes, we would back off on that. But that would be our first thing to look at.
Does anyone else have any other questions? We'll wait one more minute, but
there's 3 questions on there.
There are questions?
Yep.
Oh, I see the Q&A. I apologize. We use Teams at this place, so I'm not used to Zoom. We are in the process of reopening our company gym with some restrictions. Prior to closing the gym, we would use some large swamp fans to help circulate the air. Is it safe to use now in some type of capacity? So the problem with using swamp coolers or for your gym is that they use something called cell deck or aspen pads. Those are replaced on a semi-annual or every few year basis. They're not changed on a quarterly or monthly basis. In addition, they use, because they evaporate water from the wetness on the coils, you can have stagnant water, which can also give you Legionella. It would probably be best if you found some way to actually filter out the air, because swamp coolers don't filter. They are just all that material you're seeing, like the honeycomb style, that's not actually filters. That is just what the water is evaporated off of. So it's the same as if you didn't have any filter at all.
Right. Two things with the EVAPs. Basically, you do get some dust off of them due to the fact you do get some mineral deposits on those things, so you'll get that. Typically, you need to be sure to treat the water that's inside of them with some kind of to prevent Legionella. But as far as their impact on COVID, I mean, you're running 100% outside air in from those, so it actually increases your dilution rate. So as long as you use some normal everyday EVAP guidance, I would say that you can I don't see your risk going higher with using evaporators when it comes to specifically COVID and infectious aerosols.
So our next question is, our system does not have good airflow. We were told we would need to redo the entire ducting system. Is there anything I can do for our current system? I continue to be concerned about the air quality. Want to take that one, Dave?
Without having some specific information, we can't really offer a lot, but if you've got real low airflows, you're not flushing the rooms and you do have more of a risk factor. Some of the things you could do would be possibly to specifically address infectious aerosols would be used like upper room UV or something like that. I would, I think probably it would be worthwhile to get I don't know if they've given you any recommendations as to what to do. I'm sure there's probably, in lieu of just completely changing out a system, there's probably some things that could get you a lot better than where you're at right now. So, we'd be more than happy to talk to you about how to help you out with that. We just got to give you some, another set of eyes.
Absolutely. And just to remind you all, we are Design Mechanical, and I'm Jessica Cash, and this is David McLansborough. If there's anyone else has any other questions, you can feel free to let us know. Otherwise, we'll just wait 1 minute, and otherwise I think that kind of concludes our presentation for today.
I would just offer up one other thing that Sarah can might be able to do is if you're able to open your windows, that could be a help. That bring in some fresh outside air. And then your other option is make sure your filter is at least MERV 13 or higher if you can't really increase your outside air temperature. So those are just suggestions.
Increasing the outside air component, just like Minimal said, is basically one way that you could do it. But if you've got low airflow and all of that right now, you probably got a compromised HVAC system. So you may not have a lot of options there. If you've got operable windows, 100% agree. In some buildings, there's actually, if you open the windows, you can cause other issues. But, if you've got the issue that you've got right now, I would say definitely that would be a way to go.
In addition, if you have any VFDs, variable frequency drives, on your outside air elements, you can always talk to your mechanical contractor about revving up their motor capacity, so that with the MERV 13s, you don't lose any of the cooling or heating capacity. Unfortunately, with the thicker filters, sometimes airflow does decrease if your unit is not sized right to support it.
Right.
Anything else? Well, we just want to say thank you to Vimal and Debbie for setting this up. I don't know if there's a last poll question for anyone else left there, but we really, really appreciate your time. And again, feel free to reach out to us at Design Mechanical if you have any questions or would like some consultation moving forward.
Okay.
Thank you.
Thank you.
Okay.
So one last question. What is the replacement schedule on the MERV 13?
So the replacement schedule on a MERV 13 is mostly quarterly, just like your MERV 8s. However, I have some food processing companies that we change their filters out on the 15th of every month. You do not need to change them any more frequently than you would as a MERV 8. I would not recommend having it go any longer than a quarter, than 3 months, because the filter is, so it's going to collect particulates like the aerosols and the pollen and all the things that the MERV 8 sometimes lets through. But those finer particulates will stick to that media, and if it stays in there longer than 3 months, then you're not actually letting the air in.
So you have a pressure differential gauge on the filter. What would be the recommended pressure drop, or that doesn't matter due to the COVID-19 situation? Just change it on a regularly or wait till pressure drop?
You can do it either way. Basically, all filters give you a starting filtration rate, if pressure drop, and then a max pressure drop. So if you're switching on that, you actually get the data off of the manufacturer for that particular unit, particular filter, and then set your automation system or whatever you're using to monitor it to give you an alarm at that point. That's one way to do it, or change it on time. I think it just comes down to, every dirty environment, we had in an area where you're building brand new buildings out of ground and that type of thing, yeah, you're going to have more. But
yeah, if there's a construction site across the street from you, you're going to need to change your filters more frequently. If you live in Boulder County and it's cottonwood season, you're going to notice a quicker pressure drop. So, but if it's business as usual and you're running a municipality's building or an office, school, or commercial office space, you should be able to get along with quarterly. Your technicians servicing your building should, and also if you have a team that is, works directly for your building, internal employee, you should be dating the filter change so that when you are checking the filters, if I'm dating it June 25th, when I go and change them, September 30th, September 25th, I can look to see how dirty they are. Now, you don't want it to be like when you go to Grease Monkey and they're like, this is the inside of your car filter. It should never get that dirty. You're gonna get people sick. These small preventive measures can help prevent lawsuits long-term, prevent people from missing work due to illness. So it's really just about being a conscious citizen and protecting your patrons and your employees and your facilities.
But as far as pressure drop and as far as change out time, the COVID doesn't add a lot of load to that.
Yeah.
So again, it's virus. So, I mean, it's really just the same thing that you've always done. But it is a contaminated unit. So as Jessica talked about before, you need to treat them as a contaminated piece of equipment or contaminated filter. So bagging them, having PPE, etc. When you actually do that is probably one thing that you definitely need to do.
So I just want to make sure that I hope everyone stays safe and wash your hands and have a great afternoon, everyone.
All right, so thank you. So on behalf of the Denver chapter, thank you, Jessica and David with Design Mechanical. A great presentation. And congratulations to the 3 winners. And we'll see you next month for another roundtable, and a national, I'm sorry, not roundtable, another national. Thank you.
Have a good day.